Hi everybody, welcome back to CoderDave, where we talk about DevOps, especially with GitHub and Azure DevOps. Today I have for you a special video. In fact, in this full-length course, we will go through everything you need to know about GitHub Actions. We will start from the very beginning, checking all the things that compose GitHub Actions, like triggers, workflows, and so on and so forth. We will talk about the differences of the different actions you can find, how to create a workflow, and so on and so forth. And then we will talk about all the advanced features like secrets management, environments, and so on and so forth. This is my first full-length video, full-length course, so let me know in the comment section below if you like this kind of format or if you prefer the shorter videos. And remember to like this video if you like it or if you find it insightful so more people can benefit from it. And if you want, subscribe to this channel to have more and more content like this. But enough talking, let's go into it. Just to give you an overview, we will see in general what GitHub Actions are and how they work, how they apply to CI/CD and to release management. And then we will go in some more in-depth topics like self-host runners, build management, package management, and at the end, secret management. Let's start. So first of all, you may know that there are plenty of CI/CD systems, right? Starting from, Circle CI, Travis CI, pipelines, and so on and so forth. And Actions, of course, is one of those. But the main advantage or main advantages of Actions mainly rely on the fact that they are fully GitHub. And what I mean by that is that, first of all, they are fully integrated with GitHub. So there's no integration to make, no workaround to follow to make things work together. They just work on GitHub, with GitHub, and with all GitHub offers. They respond to any GitHub event you may have. Now, most of the CI systems you can find, they normally are used just for CI. So they respond to the fact that you push your code to your repo, or a package is ready and you can deploy it, and things like that. But for GitHub Actions, it's basically a full automation engine. What I always say is that if you think you can automate something, then 99% you can do that with GitHub Actions. When I said that it responds to any GitHub event, we'll see this later in more details, but what I mean is that you can trigger an Actions job based on things like, as I mentioned before, you pushing code to a repo, creating a new branch, but also, for example, if you create a new issue on a repo and you want to automate some behavior to respond to that issue, or a new comment, a new pull request, or even API calls, and so on and so forth. So really, the possibilities are unlimited. And in fact, because of that, and also because, as I mentioned before, they are fully GitHub, they are also community powered. And in fact, we have thousands and thousands of pre-built actions that come, of course, from first-party companies like GitHub and Microsoft, and third-party companies like all the major players in the industry. But the majority of those come from the community, meaning that there's someone like me or like you that decide one day to say, okay, I want to automate that specific task. I want to make some GitHub action for that specific operation. They make it, and they make that available to everyone. It's fully open source. All the actions are created in the open. You can see the code at any moment. And they work basically on any platform using any language and in any cloud. And we will see these in the next slide. First of all, you can run your action workflows in many operating systems. You can run it on Linux, you can run on Mac, on Windows, and on containers. You have something like matrix builds. And again, I have more details of this later, but basically means that you can write the job like once, and then having that job, having the same operations and task executing n times or multiple times based on the parameters you pass to the matrix. Again, we will see an example later. We have a very powerful logging mechanism, which allows you not only to see the logs in real time of what's happening in your GitHub Actions workflows, but also you can search through the logs, you can download the logs, and you can also link to a specific, or you can create a link to a specific row in the logs. and reference that in your issues, in your documentations, and whatnot. There is a built-in secret store, and which will be the topic of our last module. And more importantly, they are quite easy to write and very easy to share. They are all based on the GitHub workflows are, the actions workflows are based on YAML. The actions themselves are basically based on JavaScript, or you can use any sort of language that somehow compiles to JavaScript. And as I mentioned, they are easy to share because they are developed in the open. So as long as you have a link to the marketplace, or link to the repo that hosts that action, you can just share that, and anyone can use it. We will see this in more details later, but basically, this is just to show that you can do anything and everything with GitHub Actions. If we talk about CI, if we talk about building application, if we talk about deployments, if we talk about containers, or all the other automations I mentioned before. All right, so how does an action workflow works? Well, any GitHub Action workflow, or any GitHub Action in general, is composed by three main parts: the events, workflows, and actions. So the flow here, as you can see on the slide, is that everything starts with an events. Events, we will see in a second, can be many different things, but in general is something that initiate or trigger an execution of a GitHub Action workflow. And then, of course, we have the workflows, which is basically the structure, the orchestration of all the tasks and operations that your workflow or that your GitHub Action does, and that you need to perform on your application or anything else. And in the workflow, you're going to specify your actions, which are the individual tasks, the individual operations that you use to achieve whatever your goal is. Let's focus on events. As I mentioned before, everything is YAML, as you can see in the right side of the slide. And the events, or the triggers, are basically the first part that is also specified in the YAML. You have the on clause, and after that, you can have all the events. As you can see here, it can be some sort of more traditional events, like pushing the code, having a pull request, and so on and so forth, or can be on a schedule, like in the example in the slide, which will run the action at a predefined interval. Or we can even use something like the workflow_dispatch event to trigger the action workflow manually, or something like the repository_dispatch, which basically allow you to trigger your actions workflow using third-party system, whether it's API or webhooks or anything like that. And of course, you can combine those triggers together, as we will see in one of the examples I have later, in which I have a schedule, I have a push and pull request event, and I also have a workflow_dispatch event, because I want to be able to trigger that action manually. And as a general best practice, it's recommended usually to add the workflow_dispatch to your actions workflows, at least during the development process. So when you are actually creating your workflow, because you want to be able to debug and try out your workflow without maybe pushing some code every time to your repo, or creating issues and so on and so forth. When it comes to workflows, instead, you can think of workflow like, if you're familiar with the pipelines in Jenkins or in Azure DevOps, it's basically the same concept. You have all the code, all the YAML in this case, that is useful to describe basically all the operations and basically what you want to achieve and how you want to achieve that. In fact, in this example, we have that strategy with the metrics, and these express what I was mentioning before, meaning that in this case, for example, we have a matrix with two variables, the node version and the OS. And you can see we have three values for the node version, the 8, 10, and 12. And we have also three values for the OS. What will happen in this particular workflow is that the job you can see that is called build will actually be executed 9 times. And the beauty of this is that I have to write it only once. I have those steps there, and I write that only once, but automatically GitHub Actions will execute that 9 times based on the different variables I have in my matrix. 9 times because will it be executed once for macOS with the version of Node 8, another time with macOS and version 10, and another time with macOS and version 12, and so on and so forth. As I mentioned before, everything is in YAML. And one thing I didn't mention, and it's very important for all of this to work, all of our GitHub Action workflows need to be into the .github/workflows folder in our repo. In the root of the repo that you have to either create manually or it's created by the wizard we will see later to create workflows. But anyway, you have to add your workflows in this .github/workflows folder as a .yml or .yaml file. Still talking about the workflows, once again, first thing we have is the events, and this should be in sequence. So you always have to put the events or the triggers as a first thing in the workflow, and then you have a list of steps, which basically are the actions we can run, and that can be like the blue one, some pre-existing actions, meaning that there is this action that someone built, and you can use all the parameters of that action to do whatever operation that action does, or you can use directly shell scripts, and that of course depends on the OS you're running on. If you're running on Linux, will be Bash. On Windows, will be the batch, the command line, or PowerShell, and so on and so forth. One main difference, if you are familiar with Azure pipelines, for example, is that in Actions, in general, the most basic operations don't have specific actions, but you do it by command line most of the time. One example, for example, is the .NET Core build. If you're familiar again with Azure pipelines, you have a .NET Core task that can be .NET Core build, .NET Core publish, and so on and so forth. And you just fill in the details, the parameters you need, and then that basically translate that task into CLI, into command line, and execute that for you. In Actions, most likely you will do the same, just having this run command, like the green one you can see on screen, and just using the .NET CLI to execute that. There are, of course, a lot of other actions that are pre-built and usually are for more complex operations. Like the use Node.js you can see on screen, it's an action that does a series of things. So make sure, for example, that Node.js is installed on the machine this action is running. If it's not installed, it installs it. It makes sure the right version is installed. It makes sure that the path of the executable is in the path variable of that runner. So it does a series of things that, of course, you could do manually using Bash or whatever other command line you're using. But it's much easier to have an action like that does it for you, while the npm install, like you can see in the example, is just literally one line of command line. So most likely you will do that manually. Again, I've already talked about this. You can have a different strategy, but another thing that is very important is that runs on syntax that you can see at the beginning of the job. This is mandatory, meaning that for each job you build, and we will see later, you can have multiple jobs, but every job must have its runs on, because the GitHub Action engine needs to know where to basically run your workflow. So it needs to have something. It can be declarative, just saying, okay, I want it to run on Ubuntu 18.04, or like in this case, it can be part of a variable or a matrix to make it more dynamic. And once again, as I mentioned before, we can run those on Linux, Windows, and Mac. There are multiple versions you can use. You can use Ubuntu latest. You can use, like in this case, Ubuntu 18.04, 22, etc. Different version of Windows as well. Or you can use Docker, so you can execute your actions or your workflows in a Dockerized environment, but that would work only on Linux VMs. Right now, using Docker on Windows VMs is not supported. So keep that in mind. As I mentioned before, there's log streaming and artifacts. I will cover the artifacts in a moment. And again, we will see these later, but there is a secret store that you can use, meaning that you can consume secrets from within your GitHub Actions workflows. And those secrets can be stored either at repository level or organizations. Once again, we will see these in much greater details in a later module. But for the time being, know that you can consume variables and secrets inside your workflows. Talking about actions, those are basically the smaller modules, if you will, of GitHub Action workflow. And you can see them as basically, as the slide says, reusable units of code, meaning that, as I mentioned before, they are useful to automate operations that you will normally do. And you can use two different approaches. The usual one, the easier one, is to reference an action, as we have seen in this other slide before. You just call it by that uses clause, and you call it by basically its repo and its name. I'll have more details about that later. Or you can create your own actions. The GitHub Actions engine runs them in a Node.js runtime or within a Docker container that you can provide. And then you can reference that back to your repo. You have to provide some sort of some files. You have to have an action.yaml file that contains basically the metadata of your action, as you can see in the lower part of the image, which is basically similar to a package.json file. You have the inputs, the outputs, and other metadata. And then you have to have this index.js, which basically is the main file for your action. It's basically the entry point, if you will. And then, of course, you can split your action in many other files, but these two files must be there. Even though this is executed, as I mentioned before, within a Node.js context, you can use to develop your action basically any language, as long as you can convert that into some sort of action, some sort of JavaScript. For example, there's an SDK that allows you to create your actions in .NET. And you just, instead of compiling the normal .NET, this SDK, when you compile, basically translate your code into proper JavaScript for GitHub Actions. And so you can basically create your actions in that language as well. There are also, of course, some sort of control, especially for organizations over actions in general. And those are the administrative features that you can see on the slide. It basically allows you to decide what kind of actions you want to be executed in your environment, in your organization, in your repo. I'll have this covered in the demo later, but basically you can just choose if you want to the users to use any action available, either publicly or privately. If you want only your self-developed actions, or if you want to have public access, but only to a list of actions that you decide. This is usually down to the users. Personally, when I work with our clients, I don't recommend them blocking the marketplace, because there's so many actions that are available, and if you do so, you will greatly restrict yourself. What I would normally recommend, since this is YAML and it's basically merged back to your main branch in your repo, I would rather recommend them to keep the marketplace open, and then just do a proper code review whenever a user add or change GitHub Action workflow. So you make sure that the actions that have been used are safe, and you can check the code and so on and so forth. As I mentioned before, normally the actions are in the .github/workflows folder in your repo, right? And you can store there also your local actions, meaning that if you develop an action, you can save your code in your own repo and use it from there. But of course, you can, and it's encouraged to share the actions with other repos and with other users. In this case, you can just create a repo for that specific action. And in fact, if we go back to the previous slide, if you see the Node.js example, the structure for calling that is actions/setup-node. What that is basically saying there is a user on GitHub, which is called actions, which in this case, of course, is the official user, the official owner of the actions from GitHub. And that user or organization has created a repo, which is called setup -node, in which they have the actions.yaml file. They have all the JavaScript files for that action. And this way you can reference that action because that repo is public. So again, the syntax would be user and organization / name of the repo. And then you have a version that you can consume based on tags or releases. You can do the same with your own. Keep in mind, though, that if you decide to share actions, the repo must be public. So you, for the time being at least, there is no concept of private or internal repos for actions. The repo must be public. To recap, these are the types of actions that we can use in our workflows. There are mainly two types, as we said before. They are the JavaScript actions that can run on Linux, Mac, and Windows, and that can be written in basically anything that compiles to JavaScript. They are executed into Node.js environment or context. They are usually faster than the others, especially for startup time. The user experience is generally a little bit better, not in terms of logs or features, because basically they have the same features, but more, as I said, it's faster, it's easier to understand because you can go directly to the repo and check the code and so on and so forth. And then we have the container actions, which again can run only on Linux for the time being at least. And this one though can be written in any language, because at the end it's just the container that runs in the runners. It's not the code itself. So it can be whatever. You can write code, your action in assembly if you want to do that. Not sure why you would. They are slower. The GitHub Actions runner has to pull the Docker image or the container image from whatever repo it's stored. Usually it's Docker Hub. It needs to decompress that and do all the things Docker does. So the startup time is generally slower than the native actions. But of course, they give you much more flexibility. One thing I want to point out is that I'm not talking of executing or running your GitHub Actions runner into Docker. This is something I'll cover later. This is a single action, like the use Node.js we've seen before. With the same kind of syntax, you can reference another action that instead of running directly on your runner, will spin up a container inside the runner itself and run within the container context. Right, this is just the GitHub Marketplace where you can look for actions, and you can see we have Cloud Foundry, we have Snyk and Docker and Veracode, and you name it. All the major players in the industry are present in the marketplace with one or more first-party GitHub Actions. Let's see some example of actions, and then let's see some demos. This is an action that doesn't have anything to do with CI/CD, and it's to prove the point I was mentioning before. This action just check if an issue is stale or a PR is stale, meaning that it's not been updated for a certain amount of time. And if it finds any, it will push a comment to the issue or PR and just close it down. This is something that is super useful. It may not be very useful in some sort of enterprise context, but it's super useful in open source projects, because you may have issues and PRs there for quite a while, and then it just basically pollute your own repos. So this is something you can do with GitHub Actions, and you just can get this action, fill in the arguments or the parameters present in that, and you have it running on your repo, maybe in a scheduled basis or whatnot. This screen here is how you can create an action. You can follow the link down below. You can just follow the instructions and create your own action. And I think this is a very good point. It's important for you to know how to start that. You can, of course, go and take another actions code and change that. Please check the license before doing so. But in general, that should be possible. Or you can, again, create one yourself. If you create your own action, though, keep in mind that there's two ways to do so, and sometimes makes sense using one another, but usually it makes more sense using the other approach I'll show you in a second. So the first approach would be creating a monolithic action. And what I mean by that is an action that does a lot of things. Like in this case, you can see that, for example, the two first actions we have, the purple and the blue one, are just built-in actions. But then the one in green is something that is customly created. So what you can do in this action is create a release, do some other operations, and send a tweet to Twitter. Now, this is not necessarily a bad approach for this specific case because you can keep that compact, but you don't have to abuse this. What I mean by this is that I've seen in the past clients creating a single action that does deploy and test and call some API and does other operations. So all of that in a single action. And this is not a good approach, in my opinion, because there's too much going on in a single step. And first of all, it's very difficult to troubleshoot and debug if anything goes wrong, because if that specific action that does everything fails, you don't know at the very beginning, what's wrong, what went wrong. And also, you don't have fine control on the steps and what's happening. And maybe you say, I don't want to send the Twitter anymore, or I don't want to call that specific API anymore. Then you need to rewrite your whole workflow to do whatever you're trying to achieve. While if you use what we call chainable action, it's much more granular and it's usually a better approach. And what I mean by this is, in the example I had before, I would have one specific action that does the build, one specific action that does the deploy, one that does the test, one that does the API call, and so on and so forth. I think you got the idea. In the case of the example on screen, we have creation of the draft release, we have the release note generation, we add the note to the release, and so on and so forth. This way, if you split it down, it's much easier to customize the behavior of the workflow, going on in the time. Maybe tomorrow you want to add something in between the generation of the release notes and adding the release notes to the release. Or if any of those fails, you have much more control. And also, maybe you want to fail only one piece instead of failing everything, and keep the results of the other actions in place, or maybe roll back and so on and so forth. So you have much more control, much more granular control. Of course, also the logging for this will be much clearer because you can separate in the different categories. Last thing before the demo, of course, when you create actions, action workflows, you don't have to start from scratch every single time. You can if you want, but GitHub provides what we call starter workflows. We will see that in a second, which allows you to start from a certain point, right? And we have starter workflows for the most common operations you may want to achieve using GitHub Actions, and they are usually pre-configured for languages, frameworks, or third-party providers. Like I mentioned before, you can have the starter workflow to deploy to Azure, to AWS, and so on and so forth. And one very cool thing is that those workflows are suggested based on the language, frameworks, or files that you have on your repo. You can also always create your own starter workflows to use as a sort of templates. All right, so let's see a quick demo of this. So to create a new action, as I mentioned before, you can create your .github/workflow. Let me make this a little bit bigger. You can create your own .github/workflow folder and create your YAML file in it. But what normally people would do is going to Actions and click on New Workflow. And this is where you have the workflow templates that are available for you. In this case, I don't have anything in this repo. It's just a repo for GitHub Actions. So I don't have any specific template. But for example, if I try to do the same in this other repo, and this other repo is a .NET application, you will see that the suggested templates are for .NET or .NET Desktop, and so on and so forth. So as I mentioned before, there is a mechanism that suggests the appropriate templates for you based on the content of your repo. This may not be always accurate, but it's a very good starting point for you to know, what kind of operations you can already use from templates. And as I was saying before, there's many different templates you can have. You can deploy Node.js to Azure. You can use Alibaba Cloud, deploy to ECS, or you can have proper CI-only workflows which basically have the templates for most of the most used languages. You can see PHP, R, and whatnot. There are so many that you can use. And of course, we have templates also for non-CI/CD related things, as I said before, which are, you want to send the greeting or apply labels automatically to your issues. This is the one I was mentioning before. Check for stale issues and PRs and mark them or close them or send comments and so on and so forth. So all of those come basically for free, just from Action. And if you want to use any of those, you can just click on the setup workflow, and this will create all the YAML file for you with the instructions you need for whatever you're trying to achieve. For the sake of this demo, I will just go and create a simple workflow, which is the basic one we have, because I want to show you a few things. So first of all, if you've never seen this is the GitHub Action interface. You can do this on GitHub itself, or you can use, for example, VS Code. We have an extension for that. But a good part of doing it on GitHub itself is that you have here the marketplace that you can search tasks from. The structure of the file is the same we've seen before. There is a name, there's the events, and the job, and you can have one or more jobs in this. In this case, I only have one job called build with the run zone. So this job will run on a Ubuntu runner. It's all GitHub hosted runners, meaning that you don't have to take care of the infrastructure, updating, patch, and everything. Everything runs on the GitHub infrastructure for you. And then you have your steps over here. One thing that you probably may want to have in almost every GitHub action you do, unless it's for non-CI/CD related operations, is this task over here. And this one is basically telling the GitHub Action workflow to download the content of your repo to the current workspace. So all the other operations will use or may access that code. If I want to add anything else to my GitHub Action file, I can just search for whatever I want to do. Maybe I want to set up Node.js. I have it here, or setup.net. I search for .NET, and I have this setup.NET Core SDK, or many others. One thing to notice over here is that we recently introduced this mark here, and that is a verification of the author of that actions. So in this case is by GitHub, is from Actions, so it's of course verified. But you may find third-party companies that have been verified, and so it gives you a higher level of confidence, especially to enterprise customers, that they can use that action for whatever they need to do. To add any action, you just click on the action itself. You can choose a different version if you want. I usually recommend to get the latest version available, and you can copy that code and just paste it into your GitHub Action workflow file. We all know that YAML is quite picky in terms of formatting, and then you can just fill in the different parameters you have. As you can see, another benefit of doing it online is that we have automatic linting of all the code and parameters. In this case, for example, it knows that I haven't filled in any parameters, so as soon as I do fill in, the red squiggle goes away. I think it's very straightforward. For any actions you have, you can always go and see the marketplace page for that specific action, which gives you even more instructions on how you can use that specific piece of action. And in every case, you also have the link to the actual repo where the action is stored, which you can go and check all the code by yourself if you still have any doubt. Apart from adding task, as I mentioned before, you can also have multiple jobs. So for example, I can have here another job that is called test and has to have the runs on, as I mentioned before, because it's mandatory. And then in here, you can add whatever other step you want to do whatever else, right? Whenever you have multiple jobs, like in this case, they run simultaneously. So in this moment, if I do nothing else and I try to save and run this action workflow, the build job and the test job will run in parallel. And this may be a good thing because maybe they do different things and they don't depend on one another and they are able to complete independently. However, sometimes you want to chain jobs. And of course, we can do that. We can just use the needs keyword and the name of the other job. So in this instance, for example, this test job will wait for the build job to succeed and then will start. You can find all of that in the action documentation, but I think it's a very important thing to point out because in other CI systems, the behavior may be different, and you may get confused on how these things work or don't. Last thing I want to mention, you know that in Azure pipelines, we have 3 layers, if you will, of nesting. We have the tasks, right? The normal tasks or the steps, let's call it steps like in this case. We have the jobs, and each job can have multiple steps. And then we have something called stages, right? In GitHub Actions, we don't have that. We only have the jobs and the steps. There's no concept of stage. But in GitHub Actions, the job is basically the equivalent of the stage. And I can show it to you if I show you one of the jobs that I've run. If you see this image, build, deploy to staging, deploy to dev, and deploy to productions are jobs, are not stages. The same thing I would achieve in pipelines, for example, using stages, or in Jenkins using other constructs. But in GitHub Actions, those are jobs. And each jobs can be concatenated with others, can be running parallel, and so on and so forth. But I really wanted to point out this because it's fairly different from other CI systems. And by the way, the thing you're looking now, it's the GitHub Action visualization, which has been introduced end of last year. Now we finally have a way to visualize the whole workflow, which may not be very important if your GitHub Action does just one thing. But like in this case, if it does multiple things in multiple environments and whatnot, I think it's pretty important. Last thing I want to show you is the governance around actions. So I will not go in great details in the governance, but what I wanted to show you is that whether you're working on a repo or on organizational level, you can have some sort of governance around actions. So if you go to the to the settings on your repo, you have the actions menu. And in here, you can decide for this very repo, if what I was saying before, basically, if you want to have all the actions, you can have action disabled completely, even though I would not recommend that. You may allow only local actions, which in this case, since we're doing this in our repo, not in an organization, means that only repos created by this user can be used to store actions. So you basically use only my custom defined actions. Or the other one I was mentioning before, you can create your own list of actions, putting it in here, that the user can can use to create their actions. And you can also enable now all the actions created by GitHub directly or all the actions created by verified creators. And this is probably the most flexible way, especially for organizations, because most likely they are going to trust GitHub and verified creators of actions, but then there may be some third party or community action that they want to use, and they can just add it here. Same thing you can do in an organization context. You can just go to actions again in the settings, and you basically have same kind of behavior. Note that you cannot disable actions. If you remember in the repo, we have here disable actions. You can do that at org level. And when you do this at org level, you can select if you want to apply these settings to all the repos, if you want to have these applied only to some repo. And here instead is where you can disable the actions in the repos. And then you have things like artifact log retention and some others, including self-hosted runners that we will discuss later. After seeing how we can compose a workflow, how it's made of, all the action, etc., I want to talk about how we can troubleshoot our workflows and what are some of the best practices around creating and using actions. It's fairly easy to understand what went wrong thanks to the log or to other tools, but sometimes we need to dig a little bit deeper. how we can actually troubleshoot the actions, whether we are using some predefined action or we are creating our ones. Well, first of all, of course, there's the workflow editor online. And as we've seen, it does automatic linting. It gives you some hint of, if there is any problem or anything. So if you see any red squiggle under any of your action, it's a good indication that something is wrong. But I guess we are all past that point already. So another way, of course, after looking at the log and say maybe there's nothing in the log that makes clear what went wrong, is using the action debugging. We have two things we can use. And both of those require you to set some secrets and set them to true. In some other CI platforms, you can do that with environment variables. In GitHub Actions, you do that using secrets. So you can basically have a debug for the steps or for the runner themselves. I would recommend usually starting with the step debugging, which can give you information on the actions themselves. And if you put these actions _step _debug secret and you the value as true, you will see in the logs a lot of column debug, column lines, which of course depends also on how the action has been written. But in general, will give you much more information on what exactly that action and that step is doing. And you should be able to gather enough information from that log alone if it's something that went wrong in an action, in a step. So this is the first step when you exhausted all the other ways, which is the usual log and the workflow editor. If that is not sufficient, you may try to enable this other secret, the actions _runner _debug, which, as the name says, enables you to see the logs at runner level. Now, usually, in my experience, this is very seldom necessary, especially with the hosted runners. Actually, I've never used these within a hosted runner context. But if you suspect there is something that it's making your action fail that's related to the infrastructure, you can enable these. And in this case, you will not see the logs directly in the logs window, but instead, these instruct the GitHub Actions engine to save some log files in a runner-diagnostic directory in the log archive. And the log archive, if you're not familiar with that, is something that you can download using the ellipses on the upper right of your GitHub Actions workflow execution panel. In there, you will find also this diagnostic runner. Remember to disable that when you don't need it anymore, because it's slowing down, of course, the whole execution of your workflow, and also it's creating a lot of logs and noise that you may not need. You can, of course, use also the VS Code extension to write and debug your actions if you don't want to use the workflow editor, for example, or you can use some other extensions. And finally, you can also use the nectos/act project on GitHub. You can find it on github.com/nectos/act, which allows you to run a specific action workflow locally on your machine. It has a bunch of dependencies, of course, because you need to have installed everything you need to run your workflow, whether it is Docker, whether it is all the dependencies your workflow needs. But eventually, when you have everything set up, you can run successfully the GitHub Action workflow on your machine. And that's pretty useful. It's not the simplest thing to do, but if you run out of options, that's another option you have for debugging and troubleshooting your actions. Very quickly, if you want to create an action for yourself or for your clients, there are some best practices that I would say you have to follow. The first one is about versioning. As we've seen before, when you consume an action, you consume a specific version of the action, right? Whether it's V1, V1, 2, 3, etc. You may want to create that version in your documentation, but also in your repo, so the user can consume that version. And also, even more importantly, whenever you make changes, create a new version for your action. Otherwise, those changes may impact the users that are already using that action, right? If I make a change that impacts somehow one action I created, and I have hundreds of users using that action, and that changed the behavior of the action, then everything will stop working for those hundreds of users, right? So it's very important having different version and version your actions accordingly to what you're doing. Always include documentation, and these apply to both. If you're doing it in the open, or even if you're creating an action for using in an inner source context, it's important to have the documentation, because sometimes the usage of action is not immediate. So you may want to have a proper documentation showing what parameters you need, what variables, what that action actually does, and so on and so forth. Try to create unit tests for your action, because in this case, it's much easier to troubleshoot and debug, and maintain the metadata. As I mentioned before, there's that .yaml file, the action.yaml file that define all the metadata for an action. And it's important to keep that up to date with the changes and the differences that your action may have. Let's talk now about more CI, CD, and release topics. We will see how to do CI, CD with GitHub. We talk first about CI, then we talk about CD, and we talk about release management. How this translates to GitHub Actions? Well, in this example, we have a CI workflow with a single job with 4 steps. You may have multiple jobs, maybe for testing, etc., but all is contained within the CI context, right? In this case, even though we have one single job, we have a matrix, as you can see in blue, in the blue. We may have multiple jobs running from an execution point of view, to make sure that our application works against different version of Node, like in this case, or other parameters. And all the actions are chained and composed separately as steps of that job. This example is just a Node.js application. As you can see, if you're familiar with Node, it's just installing the dependencies, running the CI, making sure the tests are executed, and uploading the result as an artifact. I don't remember if I have a slide later about this, but I want to take a second here talking about uploading artifacts, because there's once again one main difference, or one substantial difference with at least some of the other CI and CD systems we have on the market, and it's that the first party action for downloading artifacts can download artifacts only from the current workflow. And it's useful to, you have a build job, you have a deploy job, and then you consume that artifact. If you want to use an artifact from another workflow, you need to use a community action. If we analyze the actions here, remember that the checkout action, especially for CI, is basically, it has to be there, because you want to use the files on your repo. You need to download them, and this is the way to do so. It basically just clone the repo in the current runner and lets you work on those files. Most likely for a CI setup or CI workflow, you want to set up your language. We have the use Node.js here. That is the one I explained before. We've seen before the other one for .NET Core. And basically, for most languages, as the slide says, we have an action that allow you to make sure the right version of your framework or language is present on the runner to be able to use it in the subsequent steps. Most of the time, the language and framework is already installed on the runner, and this action will just pass in a very few seconds just to make sure that it's there and possibly set some environment variables. Other times, with other languages, you may use the same action, and the action will also download the specific version of that language or framework and install it on the runner. And then you have all the steps you want to use for building your application. In this case, it's just a command line for npm, as I mentioned before. And finally, usually you want to upload the artifacts to GitHub. If you don't plan to use it as an input for a CD or for a deployment, it's advisable to upload the artifacts of your build, the result of your build or of your CI into GitHub, because you will always be able to download those files. It's basically zip file to see by yourself, that all the files are there, and so on and so forth. And once again, this is done separately with a specific action, which is the upload artifact action. is make use of the GitHub provided artifact store, which is stored on the same infrastructure as GitHub itself. Of course, if you're using these on a GitHub enterprise server, this action will save it inside the GitHub enterprise server VM or the machine you're using for hosting that server. One thing that we advise most of the time to use is, if you don't have any other linter, to use the GitHub super linter. If you don't know what a linter is a piece of code that makes sure the code you write, whether it's programming languages, whether it's scripting, and so on and so forth, is correct from some sort of rule standpoint. So there are some rules for each specific language, and a linter makes sure that those rules are respected. By its own nature, a linter is normally developed for a single specific language. There's a linter for JavaScript, there's a linter for C#, there's a linter for Java, and so on and so forth. The power of GitHub super linter is that with only one component and with only, as you can see on the screen, only 5 lines of YAML, you'll be able to use these on basically any code you may have, whether it's YAML, ARM, C#, any code, whether it's scripting code or infrastructure as code, even like Ansible or ARM, everything is covered. This action, of course, will scan the content of your repo after doing checkout and identify the different kind of files you have and use the specific linter for that specific type of scripting language or programming language or framework against those files. There's a ton of customization. I'm not spending time on this right now. Go and check the repo. If you haven't used this, it's one of the most powerful tools you can use from the linting perspective. Regardless if you want to use it to deploy to dev, to QA, test, production, or whatever, it's important to know that, first of all, GitHub Actions is a fully fledged CD engine as well. Until a few months ago, we could have said that on the CI part, GitHub Actions was really good. On the deployment part, GitHub Action was not so good, or let's say had to mature more. Right now, we can confidently say that even for enterprise client, we have a ton of enterprise clients using this for deployment. This is a sample CD workflow, and it's about storing. It's about container images. This is the last step of a CI job, in which we just store the image into packages. We will talk about packages in a moment, but just say we store the Docker image somewhere. And then we have this other job, the deploy to Azure job, which once again uses the needs clause over here. And this is the name of the previous job we have over here. As steps, that just does deployment to, in this case, web app for container. So we just logging into Azure, we logging into the Docker repo, and we deploy the container. So very, very straightforward. We can do, of course, everything also on other cloud providers like AWS or Google Cloud or Alibaba, as we've seen before. This is a different example, though, because it's not about Docker containers, normal applications, if you will. And in fact, we do have the upload artifact action here, which takes all we have in this public folder, zip it, and make it available to any other job inside the same workflow. So in the other job, the deploy job, we would have this download build artifact step, which uses the download artifact and downloads the artifact, which has the same name of the artifact we created. And then it makes it available, in this case, in this public folder. If you don't specify a path, it will put it in the root directory of the workspace. And then you can use the files in there to proceed with your deployment and do whatever else you want to do. Of course, you can use this approach not only for deployments, but if you have other jobs that need to do something different, like analysis on your artifacts, or you want to send an email with a zip file or whatever like that, you can use the same approach. Not that I recommend sending an email, but you can do that if you want. This is just an example of deploying to the container service of Amazon. Same thing, you're going to create the image, save it somewhere. In this case, it's in packages. and then use the somewhere here. There must have been also some upload artifact, because we have the download artifact, and then you can use the same image to deploy to Amazon and so on and so forth. So this just to show that we can deploy to basically everything at this point, because we can deploy to any Kubernetes, we can deploy to Azure, any provider, and of course, we can deploy to on-prem. Still talking about deployments, environments for GitHub Actions is basically a logical representation of your environments, the classic dev, test, QA, production, etc. And it can represent a whole environment. So you can have dev in GitHub Actions that represent the whole dev environment you have on your enterprise or your client, but most likely would be a slice. What I mean by a slice is that most likely would be only the Azure web app you need to deploy to in dev, or the Kubernetes cluster you have to deploy to in dev. You will not have the whole environment mapped. Only the pieces of environment you need for that specific repo, that specific application or project. An important thing is that they can define their own secrets, and even more importantly, they have protection rules. So what are protection rules? First of all, we can define required reviewers. And this is what allows us to have approvals. Control on deployment means most of the time that there must be a project manager or a deployment manager, or whatever they call him, to click on the deploy button to approve a deployment in a specific environment. With the protection rules of environments, we can do that. We can set wait timers, meaning that whenever you reach that environment, Actions engine will wait for whatever amount of minutes or seconds you specify before actually deploying. We can specify branches, allowed branches for deployment, meaning that only if the workflow comes from a specific branch or branches will be allowed to deploy. This is very useful because, for example, again, in enterprise context, there's a lot of time the need of deploying only from some sort of release branches, and you can enforce that with these. These also allow for third-party integrations via APIs to simulate what, for example, Azure DevOps does with the gates. With the gates, you make sure that application is deployed correctly, or you have other tools that can integrate in that. Same thing for the protection rules in GitHub. You may have some third-party products and services, scanning your environments for security, for example, or whatever other scenario you can think of, and reporting back through APIs to to approve or deny deployment. This is still work in progress, so it's not open to use just yet, but it's just a matter of making those APIs available for third-party integrations. And still, thanks to environments, we have the deployment logs. Deployment logs that can be on multiple or single environments. I'm going quick here because I have the demo of all of these. I just want to show you in practice, which I think it's more effective. But anyway, deployment logs can be for a single environment, or like in the image you have here, for multiple environments at the same time. It gives you a complete history of the deployments by date and by user, and it gives you the state of the deployment. For example, from this image, you can see that in production, we have this version marked as active, and we have this other version marked as active in staging. We had this branch that wants to be deployed to production, but is in a waiting state, meaning that someone has to approve. And this is already superseded, and this is still active. So just give you the status of the deployment for each single environment. So first of all, how do we set and create environments? Environments are created in the settings and can be created at repo or organization level. Environments are available only in public repositories, or if you have enterprise cloud, they are available also in private repositories. Even paid for by the normal organizations, then environments are not available in private repos. Private repos, environments only in enterprise cloud. In the settings of your repo or organization, you have this environments section over here. In here, you can create environments. As you can see, I have 3 environments here: development, production, and staging. But I can always create a new one, just giving it a name and click on configure environment. When you click on configure environment, you'll be brought to the environment configuration page that, as you can see, you can also use as editing. for existing environments and in which you go and configure the protection rules. We have the required reviewers, as I mentioned before. In this moment, we can add up to 6 reviewers, and that can be users or teams that can approve a specific deployment in a specific environment. So you just search for the name of user or teams within your organization. You have a wait timer in minutes, as I mentioned before, and you can specify the deployment branches that you want to limit the deployment from. By default, is all branches, but you can either choose the protected branches using the branch policies, or you can use selected branches. For example, let's say you want to have all the deployment just from the release branches. You can do pattern matching like this to add your rule to the deployment, to the environment. We also have secrets I'll cover later. But as I mentioned before, environments can have their own secrets. How do we use environments? Well, once again, is just some YAML. As you can see here, I have the deploy to dev job, and I have inside the job just this section. It's just called environment, and you can give the environment a name, and this name over here must match the name you gave to the environment in your settings. And the cool thing is that for each environment, you can also specify this URL, which can be, like in this case, hard-coded, or if you have a deployment step that, for example, use infrastructure as code to create some resources, and therefore the URL or the IP may be dynamically created, you can use an output parameter from one of your jobs to populate the field over here. And this is very cool because when you go to the action visualization that I showed you before, you can see that the URL that is specifying that parameter is shown inside your action visualization. So if you are in this visualization, you can just click on the link and be brought to the environment or to the application you've just deployed. The only requirement for this to be shown here is it has to start with HTTP or HTTPS. And then it can be a domain name, it can be just a host name, it can be an IP address, but the requirement is it needs to start with HTTP. The advantages to use that, apart from the secrets and the rules, sorry, I click on the wrong thing, is first of all, in the homepage of your repo, whenever you use environments, you have this new box over here, which lists all your environments in the deployment order, meaning that the highest one is the latest you have deployed or you are about to deploy to. In my case, is production. And you have the state, meaning that the deployment in that state, in that environment may be active, inactive, or waiting. Waiting meaning waiting for approval, and inactive meaning that nothing is being deployed to that yet, or the deployment is being reverted back. When clicking on the environments, you access the environment dashboard, which gives you the latest state for each environment and the activity log. As I mentioned before, the activity log is for either all environments, or you can select the specific environment. And once again, you have this view deployment button, which basically takes the URL that is specified for that environment and allows you to visit that page or that service. Last thing I want to show you is that, for example, you see that here I have this production, which is waiting. So what I can do is going to the action workflow that triggered that deployment. And as you can see, it's waiting for review. I happen to be one of the reviewer for this specific deployment, so I can see this. If I was not inside the reviewer team, I would not be able to see this link over here. And if I click on it, I can approve or reject, obviously, the deployment to production. I can leave a comment and deploy. Obviously, I recommend to use meaningful comments, not the one I've just left. As soon as GitHub Action Engine will take these up, we'll deploy my application. Let me go back to the slides. So let's talk about self-hosted runners. So far, all we've done was using the hosted runners, the GitHub hosted runners. Let's talk about the self-hosted runners. So what are the main differences? Well, first of all, as any hosted runner, GitHub takes care of all the updates and the maintenance and all the management and the governance around those runners. We need to remember also that whenever we use a hosted runner, we always start with a clean instance, which means that if you download a 100 megabyte file to a hosted runner right now, and in 3 minutes you try to do the same on another hosted runner or on another execution of your even same action workflow, that file will not be there anymore. You need to re-download it, right? And everything like that. For hosted runners, it's not like that, right? Everything is given back to you. So you're responsible for the maintenance. You're responsible for the updates. The script that creates or that you can use to create the hosted runner is automatically updating the hosted runner application itself, but everything else is your responsibility. And also in terms of pricing, of course, that's only up to you, whether you want to use your own infrastructure on-prem or your cloud provider or everything else. If there's any cost associated with that is on you, right? If we talk about GitHub hosted runners instead, you have a grant of minutes of execution that is part of your licenses. And then if you go above that, then it's when you start paying for the extra minutes of execution. On the flip side, though, using self-hosted runners, you have much more customization capabilities because it's your machine. You can install whatever you want, and you can prepare them as you wish with the permissions and the network connections and so on and so forth. Remember, though, that we do recommend not to use self-hosted runners for public repos because public repositories are, by definition, public. So there may be an instance in which third-party users may leverage some of the features of the application you're building or of the features you have installed on your runner to basically penetrate your network or your premises or your firewall and so on and so forth. So in general, we do recommend not to use self-hosted runners for public repositories. If you have to, try to set up some IP allow list or some stronger firewall policies and so on and so forth if you really have to use self-hosted runners for any reason. What are those reasons? Well, for example, let's say you're working on an application that is making use of GPU computation. In this moment, we don't have GPU hosted runners. So if you want to build or to use GPU for your application, you will need to use self-hosted runners, for example. Configuring self-hosted runner is really easy. If you go to the GitHub interface, we have some scripts for you. Whenever you're trying to register a new self-hosted runner, you execute the scripts in the machine you want to dedicate for your self-hosted runner or runners. You start the configuration and you use the personal access token generated from GitHub to authenticate that runner against your instance or your organization, your repo. And when all is done, the hosted runner will register itself on your, again, repo or organization and start listening for jobs. That's all you need to do. As I mentioned before, everything is on you. The maintenance is on you. The installation of the dependencies is on you. So if you need to work on .NET application, you will need to make sure that the .NET framework is installed on the runner. And so it's for Node.js, and so it's for all the different applications, frameworks, and dependencies you may have for your applications. And you need to keep that updated by yourself. Whenever you have self-hosted runners, you can create runner groups, which basically allow you to, as the name say, group pools of runners together for mainly two things: to scope those runners to specific organizations or repositories. Maybe you want to have, some pool of runner for one team, another pool of runners for another team, and so on and so forth, so they don't conflict one another. Or for specific technologies, maybe you have a pool of runners with GPU. Maybe you have a pool of runners with a lot of memory, or maybe you have one of only Linux and one only Mac, and so on and so forth. So you can group all your runners in these groups. You can always move runners between groups, but remember that one runner can only be in one group at a time. There are some things to be aware when we configure self-hosted runners. The first one is that it's advisable to create a dedicated user for the Action Runner service in order to avoid any possible, password expiration or path expirations and so on and so forth. Most of the actions may need to run sudo commands for some of the operations they have to do. So it's advisable to enable some kind of limited sudo instead of giving like root permissions. If you give root permission, then any action will be able to do anything in your runner or environment. And as I mentioned before, it's advisable to create multiple pools with specific tools. What that means is that, for example, you can have, the runners for building and deploying your Java application, the runners for building and deploy your .NET application, and so on and so forth. It's not a requirement. You can obviously have .NET and Java on the same runner, but especially if the teams are big and organization or sub-organization inside an enterprise require different things, it's advisable to have multiple pools for that. Running or executing actions runners inside Docker is not currently supported. So we can execute the individual actions inside Docker, but the runner itself, it's not supported. That doesn't mean that this doesn't work. If you look online, there's plenty of people that have some sort of workaround to make the runners run inside Docker to be able to scale or run them inside Kubernetes or Cloud Foundry and whatnot. But for the time being, it's not officially supported. And mainly the reason is that the execution of Docker actions when you run a runner inside Docker doesn't work. And there's a lot of actions that require Docker to work. So that's a big limitation at the moment. And this is the reason why it's not officially supported. Just want to make this clear because I had a lot of clients asking me for this and they wanted to execute the runners inside Docker. Technically speaking, it works if they don't use Docker actions, but it's not officially supported by GitHub for the time being. These I already mentioned, so try not to use or advise the clients not to use self-host runners with public repos for all the reasons we've mentioned before. And even if you don't use Docker runners, there is actually there are different ways to dynamically scale runners depending on the infrastructure you're using. This example is for AWS, and there are different examples for Azure and other cloud providers, or even if you use Cloud Foundry or other Redshift, etc. on-prem, you can do so. And there are these projects already built. They're not first-party projects, they're community projects, but they're used around the globe. All right, so let's move on to secrets management. GitHub Actions can use secrets, and you should use secrets. There are secrets that are already part of GitHub, like the GitHub_token you see there. This is a token that is automatically available to all the actions running in a specific repo. It's a secret that gave access to that action, basically to the repo itself, to do some interaction with your repo. You don't have to use it, but if you need to use, and some actions actually require that, you can use it, and normally you pass it within the environment variables for that specific action. It's an automatically generated and available secret, which actually is generated differently for each of the action execution. So even if it's basically impossible to grab, but if you, for any reason, you're able to grab it, you will not be able to use it because in the meantime, it's already changed. There are secrets, of course, that you can create and you can save in your repo or in your organization. And whenever you do so, and I have a demo later, so I will not stress too much on this, but you can use them just using the secrets the name of your secret syntax. You can manage the secret using the web UI or using the CLI that GitHub provides. It has some limitation that we will see in a moment, and you can access them via APIs. As I said, there are different types of secrets, mainly organization secrets and repository secrets. As I'm saying, the organization secrets are defined at organization level. They can, of course, be used, though, from all the repos in that organization. They can be scoped to all the repos or to specific repos, but they are not available in the free plan. They are only available if you have a paid plan. The repo secrets instead are available with any plan, including the free one. And as the name says, they are scoped to a single repository. They can be used to override org secrets, meaning that if I have a secret ABC at organization level and I create a secret ABC in the repository level, then the actions will use the repository secret instead. If not, it will fall back to organizations. Finally, we have the environment secrets, as we've seen before. Those secrets apply to a specific environment. And again, they override both the org and the repo secrets. The good thing about this is that only the users that have specific permission to that environment can add and edit a secret. To recap, organization secrets are the higher level. We then have the repository secrets, and we have the environment secret underneath. And whenever a GitHub action runs, it will first check if the environment is if the secret is present in the environment. If there's no secret with that name in the environment, it will follow back to the repository. And if you are in an organization context and there's no secret with that name in that repository, then it will follow back to the organization secrets. If the secret is not present in the organization, then at that point, the action will fail because we'll not be able to find that specific secret. Let's talk about some limitations of secrets. First of all, secrets cannot be read in apps. So if you have an app, even if it interacts with actions, secrets cannot be read because the Actions API don't actually have a resource for the value of the secrets. So APIs does not provide secrets, basically, the value of the secrets. The secrets are not passed to the workflow if you're executing them in a forked repo. Basically, if you fork the repo, you're not forking the secrets. You can enable, though, this for private repos, but it's a little bit of a stretch because probably want to have different secrets for forked repos. So this is why by default this is disabled, but if you want, you can enable it. But for public repos, secrets are not forked, basically. There's a limit on the number of secret and that you can use, and is 100. And there's also a limitation on the size of any given secret, which is 64K. If you need to store something that is bigger than 64 kilobyte, then the way to do this is to encrypt the secret maybe in a file, for example, using GPG, saving that file, the encrypted file in your repo, and then save the encryption key as secret of your repo or organization. In this way, you can somehow bypass the limitation of the size using an encrypted file, basically. Let me show you these in practice. So let's start with the organization secret. So this is the organization. And if I go down, I can see these secrets inside the organization. When I create a new secret, I can give it a name, I can give it a value, and I can decide to which repo I want to scope that secret. Can be all repo, can be only private repo, or as we've seen before, I can select some repo I have in my organization. If I save this secret, I can see that I can update a secret, I can remove a secret, but I cannot see its value. And even if I click on update, I cannot see its value. I can only enter a new value. This is a security feature because we want to be sure that no one is ever able to access secrets. And same thing is for repo secrets. This is repo level view. So I can go to the settings, I can go to the secrets, and I once again can create a secret. Of course, I don't have the scope selection here because if I create it in a repo, that will be automatically scoped only to this repo. And as you can see, I do have repository secrets. And once again, I can update it and I can remove it, but I cannot see their value. And finally, you can see also here, but let me go to the environments. You can see that we can define secrets also in the environments. For example, I have one secret in the production environment. And there is same thing. I have the name of the secret. I can update it and remove it, but I cannot see its value. And if we go back to the secrets, you can see that I have two secrets, this one and this one, with the same name. In this specific example is a Azure subscription ID, and which means that if you remember in this repo, I have the action that deploys to development, staging, and production. So whenever it tries to deploy to development or staging, since I don't have a specific secret in that environment, actions will use this secret. But when I'm trying to deploy to production, then actions will use this other secret over here because it overrides anything else. Last thing I want to show you about secrets is that even if I try to log my secrets in actions, I will not see the value. For example, I have this GitHub action over here, which is, it's very, very simple. And the only thing it does is trying to print out the value of my secret, which I created in this repo. As you can see, the way to use the secret is with this notation over here with a dollar bracket secrets dot name of your secret. And if I try to execute this, I can execute this manually because I have this workflow dispatch event, which, as I said before, allows me to trigger an action workflow manually. So I can go to actions. I can go to try log secrets, which is the one we were seeing. I can run the workflow manually. And by the way, I can add parameters in that event to add specific custom field here to type something or select something that will be passed to the workflow. Anyway, if I run this workflow, I can see that it's executing. And in a second, when it runs, I should be able to see that no secret value is logged. And in fact, you can see that is, being replaced by stars. And also here. This is, again, another security feature that prevent leak of secrets. And still talking about secrets, if you come from other providers or other CI system like Azure DevOps, you know that you have ways to, for example, integrate directly with third-party secret providers like Azure Key Vault. We don't have this capability in GitHub at the moment. However, we do have in the marketplace the actions for consuming those secrets. For example, if I search for Key Vault, I can use this action to connect to my Key Vault and fetch one or more secrets. And those secrets will be set as output variables from this action. Meaning that if I execute this, before the steps in which I need to use the secrets, then I can always reference that secret from the output variables of this specific action and use it in my workflow. Last thing kind of related to this, or actions in general, is that basically everything you can do from the UI in actions, you can do it via APIs. The only thing that is not available is the secrets value. You have the APIs to manage and update the secrets, and so you can do it also via CLI, but you cannot see the value because, again, we cannot see the value even from the UI. Everything else, if you want to access and manage artifacts, you want to see the workflow status, the information about your jobs, the information about everything else, trigger actions, and you name it, those are available via API. If we talk about automation parameters, if you will, in the repository dispatch, you have these other syntax in which you can pass basically an event name, and then you can reference that as client payload in your execution, right? And the way you do this, if you see here, we have these param a and boolean variables. So if I check the action that is actually calling that, you will see that I have here this client payload with param a and boolean variables that I'm passing to the other action. And I'm doing this using action here, but this is exactly the same thing you would do if you're trying to use the APIs, right? You will just create your own event type, you using any JSON payload, and then you can consume it in your action workflow the other way. You have these ifs clauses that can apply to a single action or to a job to influence the execution of the action. Let me show you something that is a little bit more meaningful. you can have different way to express it. But basically, whenever you use this if the condition is matched, then the action in this case will run, and same thing will be for the job. And you can express it as literals, you can express it as variable, or even output parameters from other jobs. So if you have a job that is supposed to do something and you want to condition the next execution of the action or a job on the base of the results of the previous job or action, you can definitely do that. I have this over here, and this is a real example because probably you want to execute this deploy to dev job only if you're coming from a pull request. So you can use the if to do so. And then you want to deploy to staging instead only if you're coming from the main branch. You can do this as well.